This is the Math 2 lesson summary video for the lesson entitled Quadratic Quandaries. In Lesson 10, Quadratic Quandaries, the purpose of this lesson is to develop strategies to solving quadratic inequalities. We use our knowledge from solving and graphing quadratic equations to solve quadratic inequalities. In Lesson 10, Quadratic Quandaries, we go back to the task Curbside Rivalry, where Carlos and Clarita are trying to decide how much they should charge for a driveway mascot. The details are repeated below. Carlos and Clarita wrote and solved this equation. If you recall from our previous lesson, we did write and solve this equation there. So we'll just talk through the steps. We do have to distribute each of these values, and we will get 2,000 plus 500x minus 200x minus 50x squared equals 2250. If we recall from our previous lesson, we do need to combine like terms and bring over the 2250 so we get 0 on one side. When we did that in our prior lesson, we got 50x squared plus 300x minus 250 equals 0. At this point, we factored out a negative 50, and we are left with x squared minus 6x plus 5 equals 0. So when we were asked to solve this before, keep in mind we did then factor what was in parentheses. We kept the negative 50 on the outside, and we factored this into x minus 5 and x minus 1. Recall that to find our solutions, then we set each of our factors equal to 0, and we solve. So I know my solutions are 5 and 1. So then we're asked, what do our solutions mean in terms of the context of the story? Well, the x represents the number of $5 increments in the price for the driveway mascots, okay? So now they're going to change what the question says. And now they're saying, how much should we charge if we want to collect at least? So now we're changing that word to at least $2,250. So we have to remember what at least means. At least means they want to make $2,250 or more. So now instead of an equal sign, our equation becomes an inequality that would look something like this. So this inequality sign means that we want to make $2,250 or more. The mouth of the inequality sign is open towards the larger number. So several ways that we can figure this out. If we'd like to, we can go to our graphing calculator and type in the left side of the inequality and then the right side. And when we graph it, we will get a line that represents the y equals 2,250, that's the red line here, and we will get a parabola that's facing down. So we can see here that we would want to make whatever this is and this is, we want to make above that or equal to that. So we just need to figure out what those two numbers are. If we go to our table, we can see that when x is 1, y is 2,250. So if x is 1, then that checks. When x is 2, we would make $2,400. So we would make more than or at least 2,250. And if we look at all of these values, when x is 1 through x is 5, we can see that all of those y values do give us a value that is at least $2,250 or more. Therefore, we would say that the solutions here would be 1 is less than or equal to x, which is less than or equal to 5. So we can write it as a range of values because it is an inequality versus an equation. The next question says, how much should we charge if we want to maximize our revenue? So think back to when we talked about parabolas. When we want to maximize our revenue, we have to figure out what that point is right there. And if you recall from Unit 5, that point would be our vertex. So we're going to have to figure out the vertex form, of this quadratic equation. So recall, vertex form is a times the quantity, x minus h squared plus k. So we're going to take our equation, which is negative 50x squared plus 300x minus 250 equals 0. And we are going to complete the square. Recall that we first ignored the c, which is the negative 250, and we're going to take the GCF out of a and b. So our GCF is negative 50, and we'll be left with x squared minus 6x when we divide by negative 50. If we recall, to complete the square, we take half of b divided by 2 squared, which would give us positive 9. So when we complete the square, we'd get a positive 9. We would have to redistribute to figure out what that c value is and see how we can go from there to negative 250. So when I redistribute negative 50 times 9, I get negative 450. So how do I go from negative 450 to negative 250? Well, I have to add 200. So my vertex form here will be y equals negative 50. Recall, we can write what's under in parentheses as a quantity squared, x minus 3 squared plus 200. At this point, we can see that my h and my k, my h is 3, my k is 200. So I would maximize my revenue if my x was 3 and my y was 200. So when x equals 3, the number of mascots, if we plug that back in, we should get 70. So this would be maximizing our revenue. Okay, so now, as we have observed, we don't get just one solution. When we're trying to solve a quadratic inequality, we actually get more than one solution. So now let's go back to another question that we were posed in Curbside Rivalry. We were given a rectangle and told that now, instead of being equal to 48 inches, we want to design a logo that requires less than 48 inches squared of paint and fits inside this rectangle that is 8 inches longer than it is wide. So we can represent the length as w plus 8 and the width is w. So the area of this would be w times w plus 8. Now, instead of it being equal to 48 inches squares, we want it to be less than. So our inequality would be w times the quantity w plus 8 is less than 48. We still need to solve this. So let's use our method to solving and figure out what our range of values will be. If I bring the 48 to the other side and I distribute the w, I should get w squared plus 8w minus 48 is less than, and that will be a 0 or a y. So there's my inequality. Now we're going to do the same thing we did when we solved. We find two numbers that multiply to negative 48 and add to 8. Those two numbers are negative 4 and 12. Okay, so now we need to figure out what these range of values are. Well, we know if we were to try to solve this, w would be 4, and w would be negative 12, according to if we're solving. But keep in mind, this is not an equation, it's an inequality. So now we have a boundary. We have negative 12 is the lowest our width can be, and 4 is the highest. So we would write that as negative 12 is less than x, or let me keep within my same variable, w, which is less than 4. So these would be my solutions. I have a range of values. Okay, So we can write that down here. Negative 12 is less than W is less than 4. Now, how could we support this answer using a graph or a table? So what I've done on the left here is I have plugged into my graphing calculator the quadratic function. If you notice right here on the left, there is a way to change our graphing calculator so that it shows a greater than or less than sign. You have to scroll all the way to the left and it will blink. And the arrow that goes up and to the right, like this, is a greater than sign. And an arrow that points down and to the left is a less than sign. So if I go back to my inequality, and it was W squared plus 8W, let me just rewrite it here, minus 48. And what I'm looking at up here is I'm looking at this part here. Notice that the inequality is open towards the y. That means y is greater than. So I chose the greater than symbol right here in my graphing calculator. So if I bring that down just so we can see, we can rewrite it as y is greater than, like so. Now notice when I graphed it in my graphing calculator, this value is my lowest and this is my highest. It's hard to see on this graph, but that's a negative 12 on the left and that's a 4. So notice that everything in between is shaded. That's because my width can be anything in between negative 12 and 4. Any point in there will be a solution to this inequality. And another way to write this in my graphing calculator is to take the left-hand side, which was W squared plus 8W, and type that in Y1. And in Y2, type in the 48, which is the 48 inches squared of paint. So the red line is the Y2. So we can see that the red line is here and the parabola is here. So our values, that's the negative 12 and the positive 4, if you look at the x-axis. Okay, so moving along, now without a context or without a scenario, we are asked to figure out how to solve an inequality. So we're just given an inequality and we're asked how to solve it. So we're actually going to just use our knowledge of how to solve an equation. We're going to do exactly what we did and we're going to factor the left side. Two numbers that multiply to negative 10 and add to 3 are 5 and negative 2. Bring down my inequality sign. So I'm just going to pretend that inequality sign is an equal sign to solve. I have an x plus 5 equals 0 and an x minus 2 equals 0. And I'm going to get x equals negative 5 and x equals 2. So this gives us our boundary points. Now, we need to now figure out if this needs to be a greater than sign, greater than or equal to sign, or a less than or equal to sign, and same thing here. So we can look at our inequality and keep in mind you can replace this 0 for a y. So if I rewrite that, I'll get y is less than or equal to x squared plus 3x minus 10. So if you think about just sketching what a graph might look like of that, I know my boundary points are 2 and negative 5. 1, 2, 3, 4, 5. There's negative 5 and there's 2. So if I want y to be less than, and I sketch what this parabola may look like, I know it faces up because a is positive, less than this graph is going to be everything out here. So that means my inequality signs need to be less than or equal to negative 5. So let me change that. X is less than or equal to negative 5. And it has to be greater than or equal to 2. So let me change that over here. Let me change that color. and I have just solved this inequality. So sketching what the parabola may look like is also helpful. Keep in mind, if you have a graphing calculator handy, you can use your calculator to graph that inequality to check your answer. So let's try another one. Keep in mind this does need to be in standard form. So I'm going to subtract the 12, and I get this quadratic equation. Again, I figure out how to factor this. So I know that two numbers that multiply to 2x squared are 2x and x. And factors of negative 12 can be negative 4 and 3, 4 and negative 3, negative 12 and 1, and negative 1 and 12. So I'm going to plug these in and just check to make sure that gives me what I want. And when I distribute, I will get 2x squared minus 8 plus 3, and that does check for negative 5. So let's take our factors and let's set them equal to 0 like we did when we solved. And we will get x is equal to negative 3 halves, and x is equal to 4. Now keep in mind, I need to sketch what the graph will look like. I know parabola faces up, but these are my boundary points. So 4 on the x-axis and negative 3 halves on the x-axis. So now I need to figure out how to sketch this. Well, there's no equal to sign. So when an inequality is not equal to that 0, it's a dashed line. So I would sketch it just like this with a dashed line. So whenever it's greater than or less than, it's a dashed line. If it's less than or equal to or greater than or equal to, it's a solid line. So solid, these two would be dashed. All right, so now with the shading, I know that if I replace that 0 with a y, that will help me tell where to shade. So y is greater than 2x squared minus 5x minus 12. So shading greater than would be inside. So therefore, I know my boundaries are 4 and negative 3 halves, but my x values are only in between those because of my shaded area. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.